In this video, we are going to look at something called composition of functions. So first thing I want you to notice is the symbol for composition. It looks like just a small open circle, but when you see that particular symbol, it means you're going to be composing the two functions together, putting them together. So in this first type of problem, they are giving me some definitions of values of functions. So function f evaluated at 3 is equal to 11. Function g evaluated at 1 is equal to 3. And so when they ask me to compose f with g at the value 1, another way that you could write this is function f evaluated at the g of 1. It means the same thing. So what I'm going to do with this is, since they told me the g of 1 is 3, I'm going to put the 3 in place of that. So then this just becomes the f of 3. And then if you look at what they defined here, they told you that f of 3 has a value of 11. So that would be the answer to that particular composition. Now, on the second type of problem, they're not giving us actual values. They are giving us functions in terms of our x's. And so when we have f composed with g, again, we can think of it as f of the g of x. So in other words, we're going to take function f, and function f has this rule where it has 1 over x. But instead of writing 1 over x, I'm going to write it as 1 over parentheses, because whatever's in the parentheses up here, we plug in down here. But we're going to plug in the rule as opposed to the function notation. So we're going to plug in x plus 4 over 5. So notice what we did is we took the rule for function g and we plugged it into function f. Now, we do have to simplify that. So that is a fraction within a fraction, and the way you actually simplify is you multiply by the reciprocal on both top and bottom. So it cancels here, and we're simply left with 5 divided by x plus 4. Now, they're bringing back domain again from our study before. And remember, with domain, we think of two things: fractions and square roots. And in this case, we have a fraction. And what we know about fractions is you cannot have a 0 in the bottom of a fraction. So whatever's on bottom, you're going to say cannot equal 0, and you're going to solve it. So in this case, x cannot equal -4. Picture-wise, it simply means there's a hole in the graph at -4. Everything's shaded to the right and left, so you actually get two intervals. So when I describe that graph from left to right, the x's start at -infinity, they stop at -4, and because they're not touching, we have parentheses, and then you put your union symbol. The x's start again at -4 to the right of it, but they don't touch it, and they go to positive infinity. So that's what the domain will look like on that particular composition. On part 2 of that same question, they turn it around, and now they're asking for g composed with f of x. So this time you're going to take function g and write it down first. So let me flip back a minute and get it. So x plus 4 over 5. But we're going to write it down as parentheses plus 4 over 5. Because then we're going to go back, and in place of the parentheses, we're going to put function f of x. But we're going to put its rule. And remember, its rule was 1 over x. Okay, so once again, if we simplify this, we can think of this 4 as 4 over 1. So if we get a common denominator on top, I'm having to multiply by x on top and x on bottom, so that I get a 1 plus 4x over x, and then over 5. And then, just like before, this is a complex fraction, so the way you get that, simplify that, is multiply by the reciprocal of what's on bottom, so that my final answer becomes a 1 plus 4x over 5x. And they may not make you simplify it. You can try it if you want. You can try plugging in this initial answer and seeing if they'll take it. They won't mark it wrong. They'll warn you if they want it simplified. So try it if you want, and that way that you'll know. But again, we go back to domain. Domain, we worry about fractions and square roots. Once again, because we have a fraction, we know that the bottom of a fraction cannot equal 0. So we're going to set that not equal to 0 and solve. Divide by 5 on both sides. So x cannot equal 0. So on the number line, you have a hole in the graph at 0. Everything to the left and right are shaded. So your domain for this one we'll describe as negative infinity to 0, union 0 to infinity. Every time you get those holes, you're always going to have two intervals that look like that.